The Kubernetes and Apache Cassandra communities are getting ready to collide in a big way, and it will make the future of both really interesting. I wanted to understand why Apache Cassandra and Kubernetes could be such a good fit. Specifically, why a Cassandra Kubernetes operator. This is where a lot of effort is being put right now. A Kubernetes operator is a foundational part of running services in Kubernetes. When you deploy an application using Kubernetes, the operators make sure all the services are working properly to support the running application. In the Cassandra world, that means a process that runs your Cassandra cluster. That sounds pretty good, doesn't it? Cassandra isn't well known for being easy to run, but this could be a huge leap forward for that story. I started asking people in the community already working on operators or with deep experience in Kubernetes, why is this a thing? I was really grateful they took the time to talk with me and help us understand the future of running Apache Cassandra with Kubernetes. Technology is great, but it's the people that make it work. Let's hear what they have to say. I asked everybody the same questions, and not surprisingly, I got a variety of responses. My first question was just about the rise of Kubernetes. Kubernetes has seemed to have won the battle for managing application infrastructure, but why is that? I asked Alan Gibson, who's a principal software engineer at Sky UK, about his impressions on how Kubernetes got to where it is today.
We've been using Kubernetes for about 4.5 years now. And in that time, we've seen the adoption within Sky grow. We've obviously seen Kubernetes mature over that time. And I think for me, a lot of it is about, if you think back, 10 plus years ago, where all the buzz started around microservices, and it was, that was fantastic. Thinking break up these big services, these big monolithic applications into your smaller, more manageable services you can reason about. And that's great. And that provided sort of one part of the blueprint around what you build, but also in terms of the transfer of knowledge as well. You think about somebody that's part of Team A working on a particular application, the way that they see the way that they see that application deployed is entirely translatable to other applications developed by other teams, because you've got this Kubernetes API that defines, all right, here how this thing is rolled out, here's the resources it uses, that kind of thing. Also, when you think about it, if you've got multi-region deployments, maybe deployments across different cloud providers, and to be able to provide that sort of agnostic API on top of the specialities of those providers, that again really, really helps.
When I asked Yelp's database reliability engineering manager, Toby Cole, the same question, he touched on a reason that a lot of projects can owe their success.
There's a lot of big names behind Kubernetes, so it can't do much harm that it came out of Google. Like, people tend to trust Google's engineering. And then you've got these other huge industry names like SAP and Salesforce and Apple, that are right behind Kubernetes in the Cloud Native Foundation.
Mike Vizard has been writing about the rise of Kubernetes over at Container Journal for a while. He counts one thing about Kubernetes that has set it apart for success in a cloud native world.
On the one hand, Kubernetes gives you this kind of cool way to converge the infrastructure in a very powerful way that's easy for developers, at least, to programmatically invoke. So you get this compute, storage, and a networking capability all in one bundle. But I think the real thing is about the APIs. I think what we're seeing here is a standard set of APIs that are exposed up to apps and databases and whatever else you have that will enable this hybrid cloud model that we've been kind of talking about for years but not actually doing.
Some interesting foreshadowing about the power of Kubernetes. But that's the application tier. What's happened with databases in the meanwhile? The application tier has seemed to have shot ahead of databases, but as I talked to Chris Bradford, who has been working with Kubernetes and databases for several years, he gives us some interesting reasons why.
If you asked me this question a number of years ago about well, can we run Cassandra or databases on Kubernetes, I would have been like, you really shouldn't do that.
Now, that's probably something you're not expecting to hear, but there are good reasons for the application tier being ahead of databases with Kubernetes.
Well, it's taken a while. If you look at most of the containerized applications that were built early on, they're stateless. It's only recently that Kubernetes has been, at least in my opinion, stable enough to build stateful apps, because you have now a decent amount of persistent storage you can call, and that's just going to get better over time.
And Kubernetes, the Kubernetes community and developers got together and said, you know what, we really want to be like the platform, and it doesn't make sense to just target stateless applications. That's not how you kind of grow in this space. Obviously, we can do that well, but there are other kinds of workloads that have an appetite to run on Kubernetes, and how can we solve that? And so they introduced new components like stateful sets and persistent volumes and persistent volume claims to describe the pieces that you need to have to operate with stateful applications on Kubernetes. And so as those have matured, our stance and really anyone's stance when it comes to running a stateful application on Kubernetes has changed pretty significantly. And so rather than saying, no, you really don't want to do that, or you really have to understand X, Y, and Z, it's more of a, oh yeah, you can definitely do that. And this is the component that you leverage, and here's why it's a good fit.
As any complex project evolves, things change, answers change. But Toby Cole points out how an open source project can drive changes. As large companies participate, they aren't giving away all their secrets, but aren't they sharing something for the benefit of everyone in a larger community?
Especially with things like Kubernetes, like open sourcing pieces of your infrastructure and getting more eyes on it has been great. It's like our platform as a service, Pasta, we open sourced it, not necessarily because we thought everyone would rush out and run the same platform as us, but because it's a way of sharing all of the lessons that we've learned. And like, I very much doubt there's that many big companies out there running Pasta, because it's, honestly, if you're not yet set up, but you can look through that code base and see what we've been up to. You can see what changes we're making recently. You can see that we've moved from Mesos to Kubernetes, and that we've like in our layer, we've got support for both. So like doing that in the open and like sharing all of that information with everyone has been a huge thing. I think that's another reason why Kubernetes has been quite a big force in services, but now in stateful services recently, because everything is out in the open.
So here we are now in 2020 with stateful applications now finding better support in Kubernetes. And as a result, many groups have started building Cassandra operators. I asked if there was a place for a common operator, or if there will always be a collection of Cassandra Kubernetes operators to choose from. Toby Cole points out some of the challenges of having one version of anything.
I think for Yelp, we'll have our own operator because we've got quite a few pieces that integrate with our infrastructure. So, for example, we've got integration with our platform as a service where we pull secrets so that all of our TLS connections are set up automatically. All of our certificates and everything are stored in Vault. It's kind of abstracted away by a layer, but no, we're secure by default. Our clients use the same platform to discover their certificates. So that's one thing where our operator, or at least we need some specific functionality in the operator. It could be that like operators go the same route as Kubernetes and have plugin architectures, but I think there's definitely a need for some sort of custom behaviors.
But Mike Vizard points out good reasons we have so many operators now, but an equally good reason of why that will change.
I think a lot of people build operators because there wasn't one available, or they couldn't find one that they precisely like, so they did the work themselves. But the core kit for building operators is centrally available, and you're basically customizing that. So there's naturally going to be a lot of people who, especially now, have a lot of spare time on their hands, and they're like, well, I'll just build an operator myself, and here we go. Ultimately, though, I think their time might be better served somewhere else, and most of them probably would rather have somebody else build and take care of the operator for them.
Now that the Apache Cassandra project has embarked on an effort to align Kubernetes operator closer to the project, we have an amazing amount of experience in the community we can tap from. Alan talks about the journey at Sky and the benefits their efforts, along with others, can bring.
I think there's definitely a place for a common operator here. I'll give you a little bit of the context around why Sky started building an operator. Mm-hmm. So it wasn't particularly because we wanted to rush into deploying Cassandra into Kubernetes for production purposes. The team I work on, the team that was building this operator, our main interest was actually to see how we needed to build and manage our Kubernetes platform so that we could actually effectively run Cassandra within it when the time came. it's probably more important that we can coalesce around a single effort. If we can get a good number of people and organizations to coalesce around a single effort, then you think about not just on the individual basis, but also on the organizations. We all have our own slight differences in mindset and the way we approach problems, the things that are important to us, the things that have value for us. And those are going to inform the other contributors in a common operator effort, and hopefully enable us to build a good, strong solution that covers a lot of the important use cases.
To bring together those different mindsets, as Alan mentioned, we need to collaborate on the important features required for a Kubernetes operator. I couldn't have asked a better set of professionals this question. Raghavendra Prabhu works at Yelp on database reliability engineering, and specifically on their Cassandra operator. When I asked him this question, he shared a great point of view on the role of a Kubernetes operator in general.
When I think of the Kubernetes operator, I usually think of it as like a proxy for an actual human being, someone in the operations team, but like a robot, but running as a software. So in that way, if I think about it, the first thing that comes to my mind is safety. What I mean by that is whenever the underlying nodes, they die, or new nodes join, the actual hardware nodes, the operator should be able to handle lifecycle management of the cluster, and scaling the cluster up and down in a seamless manner. I would say that's the first thing that that's like the primary need.
I love the analogy of the operator being a robot in your data center, but it can't be like a Roomba, just blindly banging around until everything is clean. We need to enable the operator with some smarts to make it something you can trust.
It has to understand the business domain, or the application domain of Cassandra. So there are some concepts that I think need to be baked into it from the get-go, and what I like to call table stakes. And if I'm looking at open source Cassandra, or any Cassandra really, and I'm thinking, what are the tenets for running a successful cluster in this space? Am I looking at this needs to be multi-region and do geographic geolocation of data? Or do I need to support multiple data centers from a workload isolation perspective? One of the things that I think is table stakes as well is when you start talking about connectivity to the Cassandra cluster. If you're running your application within Kubernetes and you're talking to a Cassandra cluster running within the same Kubernetes cluster, that's pretty easy. You just say, okay, here's my service, and it points at all my pods, and away we go, and we're happy. But what if you have a legacy application, or an application that exists outside of that Kubernetes cluster? What if you have an application in a separate Kubernetes cluster? How do you handle that discovery and communication across boundaries? Is it simple, where you just have a super flat network and every container can talk to every other container? Or are you more security focused and you have different rules in place? What does that look like?
How we network a large-scale distributed database like Cassandra is definitely on the critical path. But this isn't just something on the operator to handle. Changes will need to be made on the Apache Cassandra project as well.
When we start working on Kubernetes, it likes to do things like reuse IP addresses. And inside of the core of Cassandra, we talk about IP addresses and ports all over the place. Kubernetes is like, I really like host names, so I can change the IPs on as I see fit. And it'd be nice to see some of the bridging between those, what the requirements look like for each of those technologies.
As someone who works on the Sky Cassandra operator, Alan Gibson seconds the need for features that make Cassandra a great fit for distributed applications.
So you think about one of the great examples is if you run Cassandra in multiple data centers, and you obviously have the gossip that goes across those data centers to keep everything in, in sync, to keep the cluster functioning effectively, and that requires you to be able to do pod-to-pod networking between Kubernetes pods that are in different Kubernetes clusters, which isn't something you get out of the box. And there's a lot of Kubernetes deployments don't do that. There's a lot will never need to do that. So when we were thinking forwards about what we need to do, then that was one of the top things. That's where we started building the operator. I think one of the important things is on both sides, on the Kubernetes side, also on the Cassandra side, that we don't make compromises. So we don't say you can run Cassandra in Kubernetes, but you can't do this, which comes down to the multiple data center thing, where you do have your two DCs. One is running here, it's on one particular cloud provider. You get one running here, it's on another. You've got another one that's running somewhere else, and it's on your own data center.
Making sure that Cassandra can be as awesome as it can be is a great goal. But as all of these experienced Cassandra admins tell us, things that make your ops life boring can be considered a killer feature.
Other thing which has been very useful to us is that operator, again, as it comes, this is like a robot, right? So it should always have a way to, it should always have a fallback in place, so it should be able to do critical operations, such as decommissioning the node. But at the same time, if it's not sure, it should always have a fallback for human operator to step in, which means that there should be a way for a human operator to come in when intimated by, any signal from this operator, to pause this operator, to pause the Kubernetes operator and do things yourself, and then, resume it. One other thing I want to add here is the deployment safety. Because with the operator in place, you'll have your cluster in the continuous integration deployment pipeline, right? So you need to be able to deploy things safely and in such a way that if something is not good, it does not end up deploying to all the other clusters. Most of the organizations will have like a lot of clusters. Like we have like 10, 15 clusters. So we don't want, like, if we are pushing some package update, we don't want it to break everything. If it breaks on first one. So that's something which I would consider very vital.
More teams start working with Cassandra Operator, we can continue to hone its abilities with a clear pathway provided by the Kubernetes community. As Chris points out, this is already something that exists that the Cassandra project can take advantage of.
So Operator Hub is a website where you can get operators for different technologies. Mm-hmm. And they have a 5-point scale for how mature is your operator. And that's very fascinating, where it can just be like, I install things and you're done. Or it can be proactive, such as I monitor your instances and I see that one of them went down and I can make sure that we start one up. Or if there's timing between starting different instances, that's kind of fascinating when we talk about Cassandra. You don't just start all the nodes at one day. Whoa, maybe we have a cluster. You have to say, okay, well, we start these nodes first, these nodes second, these nodes third, and an operator, some of the more interesting operators, complex operators, will handle all that timing for you.
To a certain extent, like automating away the toil, making sure that all the maintenance tasks that you would usually have to go off and do, like, running cleanup after scaling and things like that, all of those little things that sometimes you forget to do, or like there steps in runbooks that could be automated pretty easily, automate all of that away just so that you don't have to think about it anymore. Like encoding best practices, taking care of like all of the manual tasks that you'd have to do when you're scaling up and down a cluster or trying to balance data, like all of that stuff, doing that for us is huge. So like, you can just change a number in a YAML file, check it in, and then come back in 10 minutes and it's done.
Making a database more boring for people running them would be an excellent mission for the project. But as any experienced engineer knows, highly opinionated infrastructure can be limiting, and as Alan points out, should totally be avoided.
If I saw things that were going too widely outside the core Kubernetes API, or if they required you to use specific other things deployed on top of Kubernetes that you may not otherwise have there, if they tied you into certain things, if they tied you into, I don't know, shipping your logs or gathering your metrics in certain particular ways, or sort of denied the user of that operator a bit of flexibility. If they tied you into, I think it's also important to tie you into specific versions and things that would make upgrades harder. I think that's another thing that would sound alarm bells.
As you can hear from those with experience, even the most modest goals for a Cassandra operator could radically change how we use Cassandra. Lowering the amount of effort to run on a distributed database and aligning closer to the application tier will give developers a lot more options. So what does the future of Cassandra running on Kubernetes look like? What new use cases do we enable?
You also think about sort of on the side of Kubernetes enabling these more complicated deployments. Now you've got, in order to be able to reason about them effectively, there's a lot more data you actually need to gather so that you can see what's happening, what's going where. You think about maybe you've got calls come into your system that need to go through 3 different services, then off to maybe 2 backends or something like that. And that there, if you think about that on its own, that's another complete story about data. that we need to think about managing, being able to search that, collect that, store that, do interesting things on that, so that we can actually have a good picture of what our more complex deployments are doing. There's a really great use case for Cassandra and Kubernetes that we've got here at Sky that actually it was a proper real use case. Basically, we had a fairly complex migration to do from one cluster to another. It was imperative that this migration was a zero downtime migration. So obviously, before this went anywhere near production, we wanted to make sure it was thoroughly tested under various different conditions. We were able to, using our operator, stand up Cassandra clusters of different configurations, different topologies, very quickly, very easily. Run the tests that we needed to run. Based on the results of that, we could very easily make adjustments, redeploy, rerun, and the turnaround time for our testing process on this was absolutely phenomenal.
The freedom to make changes, to understand how things will run in the future, and take away the amount of effort to do the right work is very powerful. For developers, as Alan mentions, this now reclassifies how databases are perceived.
It just gives you the facility to stand up clusters for very, very bespoke reasons, have them for particular purposes, use them. I guess it's sort of effectively using like tools. And I think that's a really, really powerful thing. We should be moving to a world where, all right, we move this database in and we get certain things for free effectively, or not, if not for free, but we can actually use the same concepts that were there for the last database that you put into your Kubernetes cluster. And I think that should be a value.
As Alan talks about how a database seamlessly conforms to the rest of the application tier, this is not a new concept to teams that embrace the cloud-native way of life. And as we move forward to a world of cloud-native data, Chris talks about how that could radically change the way we build applications.
And that's where I think our future state is. It's turnkey in a way that we kind of saw with the rise of cloud players, where you can say, this is what I'm looking for, and all of that automation happens for you. And cognitively, you can focus on your application or your business needs and think less about what order do I start these nodes in again? Or did I run the backup? What's the schedule for that look like? Or we're getting ready to change our logging solution. This is going to be awful. Like, it would be really nice to not have to have that cognitive load, that cognitive burden, and just be like, okay, we can do that and get on with the more interesting parts of our day. I love to put my operator hat on when I start thinking about distributed systems and Cassandra. I'm like, well, it's kind of awful to think about some of the things that we had to automate and do to get it usable and robust. And we're next leveling that every single week, it feels like now, with the automation that's coming out.
An automated future just isn't exciting for the automobile industry. As much as I would love a self-driving car, I would like my database to run without the need of constant attention. But what about all the stages of building your application? Toby talks about enabling a critical path of building applications that could make developers' lives so much better.
For Yelp, having Cassandra running on Kubernetes in tandem with being able to stream data in and out of Cassandra means that we can abstract away basically the whole concept of a cluster. Our users don't need to know which Cassandra cluster their data is living in, because as the database team, we can just move data around as long as we've got a discovery layer there. So that's the big thing that we're kind of enabled to do, is just, if for some reason we want to try a load of different settings on a cluster, we'll just spin a cluster up, move a few key spaces over, see if it works. If it doesn't work so well, we'll just tear it down again. Like, that speed of being able to iterate through different clusters, different widths, different heights, trying to figure out the optimal size and shape of a cluster. That's so much easier when you're not bound by physical hardware or even virtual instances. For us, virtual instances still take 10, 15 minutes to come up. Containers take a few seconds. Something else that's been a plan for us is using Kubernetes to allow people to run integration tests as part of their build pipelines. So they can spin up a whole Cassandra cluster, run their service against a real cluster, and then tear it down again afterwards. With the option of storing the data, because we can do EBS snapshots and make sure that their file system stays intact between builds and the servers don't have to run. or just starting afresh. But like that whole combination of attached storage planes that you can have the states of an entire cluster, but none of the compute, and just like, for 10 minutes a week, spin it up, run it. Okay, fine. Spin it back down again.
I think it enables a whole new class of workflows as well. I really like this whole CI/CD pipeline, and I'd love to talk to developers as they're building out their schema and say, okay, this is the schema you want to roll with. This is what you've checked in. Let's go ahead and spin up a cluster. Let's run some data against that. Let's see what your performance looks like. Let's see what your data size looks like on disk. Let's see X, Y, and Z, and make sure that you're checking off all these boxes as you do that road to production versus, oh, we just hit production and we didn't account for this edge case or that edge case, and it's all blowing up on us. I'd love to see this continuous data platform kind of come into existence. And I think with the right tooling in place, you can leverage it and make that happen.
Think of how amazing that would be. A completely automated CI/CD pipeline that includes Cassandra in each and every step along the way, giving you complete confidence. I don't think that future is too far away. It's really exciting. And Raghavendra adds to the awesome by not just limiting us to fast deploys, but thinking about costs along the way.
So you'll think about CPUs, memory, and disk. And also, and this is something which is very important to us, it also helps us in thinking better in terms of cost, So what I mean by that is, like when you deploy an EC2, you have a lot of system processes, and you have then you have the Cassandra running. You can use C groups, whatnot. But with Kubernetes, you can reframe your questions in terms of things like what is the cost per CPU, or how many requests per CPU, or what is cost per request, things like that. So if you can better frame that way, right, you can make better cases. And coming to use cases itself, you can make better a bargain with the management, when you are introducing something new, because now you'll have some very concrete numbers on, let's say this cluster needs to take 1,000 requests per second, you can say how much cost you can attribute to that,
Yeah, if the operator is the robot and you give the robot a task, here's all I need, find the cheapest way to do this.
Yes. Like a bill of materials, right? You give like a bill of materials, and it tries to come up with a very good optimization for how it needs to be deployed.
Better, stronger, faster sounds like a great future for Apache Cassandra. These are things that are happening today, and our community is working on them as we speak. Where will this take us beyond the current use cases? Mike glues together some interesting trends in application infrastructure and shows us the next generation.
I think we're on the cusp of some major advances in use cases, and I'll point to the edge as kind of my classic way of thinking about this. If we're starting to push more code to the edge and it wants to interact with people in real time, whether it's virtual reality type of application, or it's some sort of Uber-esque thing where the response time is real. I need to be able to see the data processed locally or as close to the edge as possible. That's going to require both a combination of transactions and analytics to be run at the edge. I think Cassandra kind of excels at that. And if we can get a version of Cassandra that plays nicely on the edge, thanks to Kubernetes, because one of the problems with the edge is there's a million different edges. I think that there's an opportunity here to drive a whole new class of real-time analytics applications that have the transactions embedded in them. And that's going to drive a bunch of use cases that may ultimately be more important than what we saw with the cloud, which basically, all we really did in the last 10 years with the cloud is lift and shift our existing enterprise architecture into the cloud. So now I got batch processing in the cloud.
Talking about the edge is definitely next generation and the future that we will try to figure out. The next 10 years of Cassandra will be amazing. It's been purpose-built for the next level applications that we are building. Cloud-native data is the next stop on this incredible journey. I was so fortunate to have some great engineers join me as I try to unpack this inevitable future. This isn't one person's vision. It's the combined efforts of our incredibly capable user community and their commitment to sharing information that makes us all better. As my coworker Sam Ramsey likes to say often, if you want to go fast, go low. If you want to go far, go together. I think that's pretty cool. This is an effort happening right now and will continue to grow over the coming years. If you want to join us, get engaged on the Apache Cassandra mailing list or even on the Apache Software Foundation Slack. We're all there. We're willing and ready to talk. Stay tuned for more content around this topic. We are only getting started.